In this video, we will cover points as solutions to linear equations. The reason why an ordered pair is important is because it can be a solution to a linear equation in two variables. When we replace that ordered pair back into the equation, its result should be a true statement. That means that the left side of the equation is going to equal the right side. So as we look at example 3, it's asking us to determine if either of these two ordered pairs is a solution to the given equation. So let's start with A. I'm going to first bring down the equation to give myself some space, and I have y is equal to 4x minus 1. For A, we see that the x value is negative 1 and the y value is 3. So what we're going to do is we're going to go and replace them in the equation. So for the y value, here we go. The y value is 3, so I'm going to replace that y with 3. Don't lose the equal sign. I have a 4, and then instead of the x I'm going to replace it with that negative 1. I'm going to put it in parentheses, and then don't forget that you have that minus 1. Okay, it looks kind of messy right now, but we're going to simplify here from left to right. Now, you don't have anything outside that parentheses for the 3, so we can just drop the parentheses altogether, and that's going to give us 3 on the left side. On the right side, I have this multiplication of 4 times negative 1, where 4 times negative 1 is going to be negative 4. And then don't forget to bring down that minus 1. On the left side again, all we have is that 3, so we're going to leave it alone. There's nothing for us to simplify. So this just left 3. Don't lose the equal sign. And on the right side, I have minus 4 minus 1. Because these are the same sign, we're going to add and keep the sign. So on the right side, I get a minus 5. And then I check again. Is there something for me to simplify on the left side? And there isn't. Is there something for me to simplify on the right side? And there isn't. So the last thing will be, is this a true statement? And it's not, because 3 does not equal negative 5. They're not the same number. That means that this point, negative 1, 3, is not a solution to the equation that we were given. So let's try B and see if B is a solution and how is it different from A. I'm going to bring down the equation again to give myself space. I'm going to replace this time the x value with a 1 and the y value with a 3. So let's do that. So the y will be 3. Here's the y. I'm just going to replace it. Equals, I have a 4. And then instead of the x, we're going to put that 1. Minus 1. All right. We look at the left side. The left side is just 3. There's nothing outside of the parentheses, so it can be dropped down and just giving us a 3. Don't lose the equal sign. On the right side, I have 4 times 1. Well, 4 times 1 will be 4. Don't forget to bring down that minus 1. I check again. On the left side, I have still only the 3, so there's nothing for me to simplify. It's just a 3. And on the right side, I have 4 minus 1. Well, 4 minus 1 is equal to 3. So I check again. This is the last. There is nothing for me to simplify on the left side, and then there's nothing for me to simplify on the right side. So then all I have to do is check, is this a true statement? And it is, because 3 does equal 3. The left side is equal to the right side. So when that happens, that means that the point that we were given, in this case was 1, 3, is a solution to the equation. So then how do we know if a point is a solution to the equation? When we plug it into the equation and we continue to simplify, and if we get a false statement, this is not a true statement, then it's not a solution. But if we get a true statement, that means that the left side is equal to the right side, that means that this point is a solution. So let's try another example. Now what happens if only one coordinate is given and we are being asked to complete the order pair so that each of the order pairs is a solution? We're going to do something similar as the previous example. We're going to replace the coordinate that is given into the equation, but then we're going to have to solve the equation to find the missing value. So first, we're going to bring down the equation to give ourselves some space. So this is x plus 2y is equal to 8. And what I'm going to do is I'm going to look at the first coordinate that I'm being given. This time I'm being told that x is equal to 0. So everywhere I see an x, I'm going to replace it with a 0. So then this becomes 0, bring down the rest, plus 2y is equal to 8. Well, 0 plus 2y will just give me 2y is equal to 8. Now my variable is on the left side and is being multiplied by 2. So then the opposite of multiplication will be to divide both sides by 2. Now 2 divided by 2 will give me a 1y, and on the right side, that's 8 divided by 2 will give me a 4. Now in this case right here, when I have 1y, if you think about it, if you were to multiply 1 times 2, well, you just get back the 2. So then 1 times y will just give me y. So y is equal to 4. That means that the missing coordinates will be y is equal to 4, and this should be a solution. Now, how do we check if this is a solution? I'm going to check it here, and then I'm going to erase it because I'm going to need the space for the next point. Let's check here. The equation was x plus 2y is equal to 8. We were given a 0 for the x, and we found a 4 for the y. So let's plug it in. This is an x value, so I plug in 0 for the x value. This is a y value, so then I plug in a 4 for the y value. And then I check if the left side is going to equal to the right side. Now we're going to do multiplication first here, okay? So when I multiply 2 times 4, that's going to give me an 8. So I have 0 plus 8. Does that equal 8? And it does, right? Because 0 plus 8, that's just 8. And on the right side, all I had was 8. Because the left side is equal to the right side, this is a true statement. That means that this particular point is a solution. So if at any point in time you want to see if the answer you got is correct, just plug it back into the equation, both values, the x and the y, and see if you get a true statement. See if the left side equals the right side, then you know that you did it correctly. Let's go try the next order pair we're being given. I'm going to bring down the equation one more time. X plus 2y is equal to 8. And now I'm going to look at the second coordinate. The second coordinate that I'm given is that y is equal to 3. So that means that everywhere I see a y, I'm going to replace it with a 3. And then I'm going to bring down everything else. So I have an x plus 2 is equal to 8. Okay, so we're going to multiply 2 times 3. And that gives us x plus 6 is equal to 8. Because my variable is on the left and is being added by 6, the opposite of addition will be subtraction. So when I do that, I get x. 6 minus 6 will go to 0. And on the right side, I have 8 minus 6. That will be 2. That means that the missing coordinates is 2. Let's try it once again. I have x plus 2y is equal to 8. The last coordinate that I'm given is this x is equal to negative 4. So right here where I see the x, I'm going to replace it with -4. And then I bring down everything else. Plus 2y is equal to 8. All right. In this case, I'm going to have to move two things. Because my variable is on the left and is being multiplied by 2 and then it's being subtracted by 4, I have to decide which one to move first. And if you saw the videos on solving linear equations, I know that I have to move anything that is being added or subtracted first. So I'm going to move the -4 by adding 4 to both sides. So -4 plus 4, that will go to 0, different signs. We subtract, 4 minus 4 is 0. Bring down the 2y, and on the right side, 8 plus 4 would give me 12. Now, I'm not done because my y that is on the left is still being multiplied by 2. The opposite of multiplication is division, so I'm going to divide both sides of the equal sign by 2. Now, 2 divided by 2 will be 1y, and on the right side 12 divided by 2 will be 6. Now don't forget that 1y is just y, so y equals to 6 will be the missing coordinate. So then we ended up with 3 solutions for this equation. The first one is 0, 4, the second solution is 2, 3, and the last solution is -4 and 6. Then how many solutions does a linear equation into variables have?
Thank you so much for watching, and I'll see you in the next one.